Welcome to the Pseudo Show. This is Brandon. We've been off for a little bit, not too long as our last break. This will probably be our last break for a while, with luck, unless something else happens in our lives. Right now, Neil is starting a new job. I'm going through a bunch of things at work as well. And Bill has been traveling more for his work. Like I mentioned in the last episode, we will work towards getting back on our regular schedule of every other week on Thursdays. For now, I'm targeting once a month going forward, but that should give me a chance to catch up on editing the content that I have recorded for YouTube for Pseudo Show Labs. Today, Bill, Neil, and I discuss private cloud and a trend to returning some workloads on-prem, or in some cases, just bringing more control over how public cloud is consumed, which starts to look more like private cloud. No, we're not saying public cloud is going away, but there are some workloads won't go to the cloud for whatever reason, or it just makes more economical sense to go on-prem or use private cloud. We went on a few tangents in this one, but it wouldn't be a pseudo show with the three of us if it didn't. I think we summed it up well. So here's our discussion. Private cloud strikes back. Today's episode is brought to you by Bitwarden. Bitwarden is the easiest way for individuals, teams, and business organizations to store, share, and sync sensitive data. Bitwarden is an open-source password management tool whose feature set rivals any other tool on the market today. Not only is Bitwarden open source, it is regularly audited by security professionals. You can get started for free at bitwarden.com/tux, and plans start at just $10 per year. Thank you to Bitwarden for sponsoring the Pseudo Show. This episode is sponsored by Linode, now called Akamai Connected Cloud, a massively distributed edge and cloud platform. Sign up today at linode.com/tux for a $100 credit and start deploying workloads where you need them with predictable price models. While you're at it, take that credit and spin up a Linode virtual machine and deploy the Pseudo Show application of the month, N8N, an open source workflow automation engine. At Tux Digital and the Pseudo Show, we love Linode because they make it easy for us to spin up new services such as N8N and test them out. See what you can do with N8N and deploy it on a Linode virtual machine today by going to linode.com/tux and let us know what you do with it in the forums. Bill, Neil, it's been a while since we've gotten together. I appreciate you guys making the time again today. I think I already said this in the intro, but I know today we're going to talk about private cloud. And I have a lot of thoughts on this, and I kind of brought this up in the intro of like what private cloud is, but just to reiterate, all what private cloud is essentially just more than just virtualization with management, and it allows you to have self-service into your private cloud environment in a similar fashion that you see with a public cloud provider such as AWS, Azure, and the sponsor Linode.
I'd actually tack onto this just one more thing that differentiates cloud from just plain virtualization. Elasticity. You have to be able to provide a way to support demand-centric modeling with it. So, for example, in the event that you're like, oh, we're close to our private cloud being full because, we're out of capacity, it should be just install a new hypervisor, add it to the pool, instantly more capacity, and nobody above that layer has to notice that happened. In more traditional virtualization models, you have to be aware of where the machine is being provisioned, and you have to know where it is, and in the event that it becomes full, you have to manually shuffle machines around, virtual machines around, to make it so that you have capacity balanced out again. The key differentiator of any cloud architecture, or any cloud infrastructure, I should say, is that the upper layers, the users that access it, the consumers of the service, don't notice that the provider of the service has to do that.
So, Neil, are you saying that that scalability could apply whether you're talking about a 2-node, 3-node, 5-node, 1,000-node setup of any kind of hardware, whether that's mixed and matched between, let's say, large-scale hypervisors, or could someone even start small with a couple of Raspberry Pis in a home lab or something like that?
For sure. Conceptually, what you're looking at is you have a system architecture of some kind that involves a solution that provides I hate using jargon words, but I really don't have a better way for doing this, but a fabric, a layer that essentially totally abstracts the underlying resources that are used to something like a generic bucket of allocation that a user of this cloud infrastructure would be able to request. So that could be you are powering it by a bunch of mini PCs and NUCs and some Raspberry Pis for x86 and ARM resources. And then you get an Ampere Ultra or something like that, and you just whammo a bunch of cores for ARM. And then you get like some kind of EPYC server, and you whammo a bunch of cores for x86. And nobody notices the difference, because from their perspective, they're just saying, I need a VM with X many cores, Y amount of RAM, Z amount of storage, and it figures it out for you. And if it turns out there's a better place to put it, the fabric, management layer, whatever, shuffles things around to optimize it for you. Like, that's the kind of thing. The idea is, both from the administrative side, although this is obviously not perfect, the administrative side should be able to see the infrastructure being able to take care of itself in a demand supply centric model. Basically, you have a demand supply curve, the system understands what that is, and actually balances resources accordingly. And then on the user side of it, the consumer side, the demand and supply curve is largely invisible to them. They see the available inputs, they can make decisions on what kind of resources are that they need to use based on those inputs. They use the resource and they're done.
Typically, at least in private cloud, and you can apply this in public through managed public cloud, is quotas. So you can just say, hey, you get X amount of resources, and you will never go above that cap. Some people are now probably asking, why are these guys talking about private cloud? Isn't the big thing public? Well, Neil and I were talking about this a couple weeks ago, and we're starting to see a shift in the industry back to not necessarily on premise, just more infrastructure back under your control, which is essentially what private cloud is. It's more of your control, have more control over your destiny than just relying on a public cloud provider.
To be clear, a lot of times this does include going back to running your own data centers to some extent and things like that. But the key is that nobody is going back to, I hesitate to call it legacy, simple on-premises model where you have a DC or a colo and you have a bunch of servers and you allocate a specific server to somebody, and that person knows that it's a server, can access the server and does things to the server in that manner. Like, that model is not coming back at any reasonable level of scale. What we are seeing is people are increasingly interested in providing a cloud-like service model with their own resources rather than leveraging somebody else's.
So you make a good point, but I'll disagree with you on one side of that, and is I am actually seeing some clients of mine going back to, I want my physical box, whether it's in your colo, which we have one, or whether it's on-prem in my building, because the costs of the public cloud are getting to be such that we can no longer afford the monthly expenses. And again, I work with small businesses of usually 50 users or less. On the other side of that, last year I designed a solution for a client involving multiple co-location facilities and quotas and management and everything else for converting on-prem systems into a private cloud scenario. The ROI on that, even for standing up 3 co-location facilities, was about 2.5 years versus paying for public cloud storage and services through Microsoft Azure or AWS. So I think I'm starting to see a bit of both. I have some clients that want physical control over their bare metal, and whether that's for financial or even regulatory reasons, some of that, we'll use the term legacy management, I think is still applicable. Maybe we'll see more of that as time goes on.
I want to make it clear that just because we're talking about having like this abstraction and management fabric type stuff, it doesn't mean that you don't have companies or businesses, even small ones, wanting to own their own boxes. That is not a mutually exclusive thing. The idea, though, is even if your client, for example, has said, we want to have big box here in our room, and we want a big box here in your colo, having that unified fabric gives you the ability to say, hey, you're about to run out. Rather than having to make everyone suffer, let's pre-order a new system, get it installed, plug it into your fabric, and your users will not notice that this happened, right? So that's why I'm saying that this model isn't really coming back at any degree of scale, because people have gotten used to the idea that consumers of compute, storage, networking resources don't necessarily need to be aware that there are limits underneath it all. Usually someone else is supposed to take care of that for you. And like, that's your job, basically, right, Bill? Like, your job is to provide those resources and to support those resources for your clients as small businesses. That just happens to be, they are so small that one box tends to work for them. When it gets to 2 boxes or 4 boxes or more than that, that is when things start getting ugly, in my experience. Because once you start getting to multiple machines, and then you start having to talk about, are your workloads actually in the right place for where they should be? And what happens when you need to take a machine down? Things like that. That is where having this fabric becomes super useful. And there's a ton of solutions, open source solutions, fantastic solutions out there that you can use for this purpose. I think we'll get into that in a little bit. But like, I think that, like, to address the specific point of, like, you know, whether it's just one box versus like having a bunch of them or whatever, like, I don't think it's mutually exclusive to having just one box. It might seem like overkill up front, but it saves you effort in the long term. Like, I have been through projects where we've had to re-architect from that model to it afterwards, and they always suck. They are not fun to do, and they are really, really hard to execute on.
I want to stress one more point too. You're talking about fabric and elasticity and the ability to proactively add resources to your system. I want to add a quick aside to that. Don't forget the networking. If you're going to do private cloud and you're going to invest money into your servers and your storage, don't forget how important good networking is. Whether you have high availability firewalls, high availability switching, you ensure that you have enough throughput to your storage nodes on your switching network. You have some sort of SD-WAN implementation, whether that's MPLS, whether that's multiple fiber providers, cable, cellular, whatever else. But the advice that I could provide probably to those of you thinking about private cloud out there is, do not forget or skimp out on the networking, because without that, your private cloud won't be very accessible.
It'll also not be very performant. I have done a private cloud on one network set before, and that is how I learned you should probably have separate networking for your storage and your compute, because not doing that is a great way to bottleneck your system.
Almost every OpenStack deployment that I have had a hand in designing is a spine leaf architecture.
Exactly.
Yeah.
So for those who don't know what that means, Brandon, would you care to explain what a spine leaf architecture is?
Essentially, you have your core switches and then your rack switches, and your rack switches have, there's probably 2 or 3 in the rack, and all of them are attached to a different core switch, is essentially what the high level architecture without getting on my whiteboard and actually showing it, which I can't do on an audio only podcast.
Coming soon, a pseudo lab where Brandon talks about the cloud.
Bill, you brought up a really good point here, and that on cost. The cost of public cloud for a small business is, becomes untenable. For an enterprise, a lot of people, when they think of enterprise, they think that enterprise just has buckets of money to give to everyone. They don't. A lot of the public cloud providers are working with their enterprise clients and getting them to get into committed spend agreements. Some of these committed spend agreements, the number is outrageously high. From my point of view, from what I've seen, a lot of these are public. Go look up committed spend agreements with like Google or AWS. Like they talk about them pretty publicly. And you go, how do you spend that kind of money? Spend costs are not being met. But the thing is, though, is no matter what, whether that company hits that committed spend or not, they spend that money. Data egress charges are fantastically large in public cloud, which makes data mobility extremely difficult, which is actually really important to enterprises, especially enterprises that have traditionally had two or multi-vendor strategies to leverage better price points, or they just need better data locality. That's where edge is really coming in. I think edge is a big reason why the concept of private cloud has been talked about more. Whether if we're talking about private cloud, hybrid cloud, and edge, typically the conversation sounds like the conversations I was having with customers 5 years ago when I was talking about private cloud and OpenStack. I think another big reason why private cloud is making a comeback, especially overseas, so outside the United States, is data sovereignty. Public clouds don't have data centers in every country in the world. There are now laws in various countries, and even I believe some new laws around data sovereignty in the United States that prevent you from hosting data relating to your let's take the EU, data around European Union citizens in the United States. It must be in a data center in the EU and comply with European law. So, and that's not always you cannot always make that happen with the public cloud. So now a lot of companies have to have a data center presence or rely on other public clouds in that region. So I think that's another big reason, because the data sovereignty issue is not going away. If anything, it's becoming more important, becoming top of mind for CIOs and CTOs and the CISO office at many different enterprise organizations. So anyway, that's why we wanted to have this conversation, mostly because it's making us come back. Now, we talked about a little earlier what makes private cloud. It's not beyond just virtualization with management. It must provide self-service. A lot of people, when they think self-service today, it's going onto Amazon, clicking a few buttons and deploy an EC2 instance, or going into Linode and deploying a virtual instance on Linode, or going and really self-service has gone way beyond that. When I was originally talking self-service to my customers, it was doing that point and click, also automating every step in that process. So, do I have an IP address? Is the IP address assigned? Is DNS allocated? The whole thing have a proper approval workflows today self-service is mostly around a very developer focused, non end user focused. So it's more around infrastructure as code or GitOps, being able to deploy your virtual machines declaratively or your containers. And that seems to be where self-service has gone, and that whole concept of allowing any end user, like a project manager, to go to a form, fill out a form, and get a virtual machine is pretty much gone, which I actually think is maybe a little detrimental to some organizations, and actually puts a new barrier to entry to get infrastructure. And one of the goals of this type of like a graphical self-service was to eliminate the barrier. But I feel like now the barriers are in place. What do you guys think about that the self-service?
I think we're regressing on self-service stuff overall. Like, one of the things that I've observed is that in the I don't want to say transition, because it's not really a changeover of any kind. With the increased focus of moving towards Kubernetes as the platform for doing this stuff, we seem to have forgotten how to handle people who don't know how to deal with all the details. And I think that's going to become a major crimp in the late stage adoption of Kubernetes-based platforms. Like, there have been a few solutions out there that have been pitched to me over the years. And the big thing that I noticed was that all of them have a hyper focus on providing you APIs and automation and all that other stuff. And that stuff's great, right? Like, having APIs and automation helps make large scale stuff really easy. But it makes on-ramp really hard. It makes context management of the stuff really hard. It also makes small scale on-ramps impossible. Most of the time in a small scale deployment, to be blunt, you don't need automation for most of it. It's basically overkill. If you like automation, by all means, do it. But if you're running a couple of virtual machines and like 3 or 4 containers, do you really need automation for all of that? Maybe not. It would be a nice to have, and it can definitely save your bacon later. But that is small enough that you can hold the whole architecture in your head. That is small enough that you could just write down on a notebook or write down literary instructions rather than programmatic instructions to manage it. When you start getting to like maybe 20, 50, 100, that's when it starts becoming like it makes sense to go there. But the problem with Kubernetes right now is that when you look at any of the solutions out there for private cloud implementations based on Kubernetes, except for one that I will notably put aside and say this is actually doing a good job here, they all put a hyper focus on everyone should learn everything about the Kubernetes raw objects and how it actually implements and how you actually manipulate these things. You should be exposed to all these primitives. You should like deal with the YAMLs and all that other stuff. Like, nobody was supposed to work with Kubernetes YAML directly. Like, Kubernetes YAML is supposed to be an instructive middleware abstraction. You're supposed to build stuff on top to not deal with that.
So to your point, a couple years ago, I purchased 4 Raspberry Pi 4 units. And Neil, you've seen said units, and you know where they are, and we've talked about them before. And in fact, you and I have dabbled with them from time to time. But the purpose of those Pis were for me to learn Kubernetes. And I knew what I wanted. I wanted to get to that Kubernetes dashboard, that nice web interface, so that I could self-service my cluster. However, getting to that point never really happened because there were so many different mechanisms and methods for accomplishing their way of doing Kubernetes, and unfortunately, none of them worked for me. So perhaps a future Sudo Labs episode is us getting together and taking apart, demystifying Kubernetes and figuring out how we can make this easy for everybody, or at least somewhat approachable.
I don't know if I want to get to the point where we start talking about specific things, but I think
No,
Like
let's get specific.
okay, because like it's getting hard for me to talk in generalities because we're drilling down enough.
Oh, we're drilling down. Let's talk. Let's get into specifics.
Yeah, let's do it.
All right, sure. All right, here we go. So, in the biggest, most popular solution for doing private cloud infrastructure is OpenStack. Now, OpenStack is not a simple system to deploy. It is very much designed to be a very large-scale infrastructure platform. In recent years, they have actually committed to improving the day one and day two experience deploying and managing OpenStack. And in the last 3-ish years, I think it's improved considerably from the previous 5. Having been a former OpenStack cloud operator, it's phenomenal to see improvements on that front. OpenStack actually, I think, still does a reasonably okay job of making it possible for people to operate and leverage the cloud resources without having to resort to terminals and APIs and stuff like that. Because the Horizon interface, as interesting as it is still workable enough for people to be able to operate it without having to figure out all the nitty-gritty stuff underneath. Now, in my opinion, Horizon still exposes too much. There is still not a simple mode for people to leverage OpenStack effectively. And I like to point to Overt as an example of one where I like the experience here. Because if you look at Overt, a deployment of Overt is actually relatively simple to do. There's like a couple of commands to run, and it walks you through it. It has a nice wizard. It's now got a web-based wizard built into Cockpit. It's super cool. Setting it up, once you're done, you are presented with the ability to go into an admin portal and a user portal. The user portal provides you a very simplified view that a user can be given a quota of resources that they can use for their purposes. And the administrator can always oversee all of that. And they can see all the nitty-gritty details as needed. But the users who are actually consuming the service don't have to. OpenStack Horizon lacks that particular divide. And actually, a lot of private cloud implementations lack this currently, especially all the Kubernetes-based ones. And I think it's really one of those like late-stage Kubernetes adoption requirements is to have that capability so that people don't have to worry about the technical underbelly, the complex technical underbelly that Kubernetes requires you to be able to do a lot of stuff.
What's really cool about the Overt the user interface, I don't want to call it self-service. In the self-service UI, there are 2 personas actually. There's like a standard user view and a power user view. So the user view, what's really cool about that is it's essentially, here's your VMs that you have access to. You want to create a new one, gives you a t-shirt size and a list of images you can deploy, and that's it. A power user view has a few more knobs you can mess with. That's what I really think is awesome about Overt. It's one of the things I miss about utilizing it in my home lab. My home lab does a few other things than just provide me with my own infrastructure for me to test things. I actually used it. It made it really, I have a couple terminals around my house that defaulted to that user portal. So I could just pull up a virtual desktop pretty quickly. That was something super useful to me. I do agree with you, Neil, on the Kubernetes front to some degree. I do think partially it's at this maturity point where we're focusing so much on developers. But the thing is, those developers, they're the ones that make the apps. They're the ones we frankly need to cater to. There's still that end user that I need to be able to deploy this in a self-service way. I have seen applications that have been deployed that don't require developer intervention. That's really where I think where we're going with this. I think a couple of the Kubernetes distributions are starting to get there. I think OpenShift is going to get there here pretty soon. I think OpenShift has the best experience in terms of self-service in general. It's not as refined as as simplified. Refine's the wrong word. It's not as simplified as that overt user interface. There is a degree of self-service that you don't have to be a Kubernetes expert. Even if you are a developer, you don't need to be a Kubernetes expert to use OpenShift. I think that's its strong point, and I think that's where most, not all, I mean some of the other Kubernetes distros are following suit. I think OpenShift's strongest selling point.
I ran an OpenShift 3 deployment for 5 years in production, and OpenShift 3 was no cakewalk to run as an admin, but you can very clearly see that there was a philosophy around providing an opinionated, simplified workflow to leverage the architecture to the best that you could. We've kind of taken a little bit of a step back, I feel, in OpenShift 4 as we've integrated a lot of third-party CNCF projects into OpenShift. But you can still see that the underlying philosophy is there, and I think that they will... I hope that they continue to go down that road, because it makes for... I think it is the true differentiator there. And I've seen other Kubernetes distributions starting to pick up on this and realize that this is something that matters. Making the overhead of adopting a platform and using it effectively low benefits not just developers, but everyone. And that's a very, very big deal. In the virtualization space, there's a lot of interest around Kubernetes-centric virtualization. And the one I've been keeping my eye on a little bit has been the Harvester project. Because one of the things that they tout is providing that simplified experience for virtualization on top of Kubernetes in order to displace things like VMware and whatever. Now, I don't know if Harvester is going to be the right answer for this. My brief forays into it have been interesting. But I would personally love to see that overt virtualization experience on top of OpenShift someday. And that would be, I think, in my opinion, a really solid contender for providing a simplified experience for KubeVirt-based virtualization. But we got to take a step back a little bit. We've been talking a lot about Kubernetes and OpenStack and the developer experience there. We haven't talked a whole lot about the administrative experience, which matters a lot too. And this is where we start getting into how do these private cloud operators actually manage these deployments? And this comes back to something that I don't know if the industry talks a whole lot about. I mean, I certainly have only recently started hearing the term thrown around, is bare metal as a service. And there's a number of different projects out there that do this. A personal favorite of mine is Uyuni from the wonderful folks at SUSE, who basically forked the Spacewalk project that Red Hat made and enhanced it with all kinds of other fun capabilities, including fully functioning large-scale bare metal provisioning.
Uni is interesting. I remember when they did that, and it's like, good luck with that technical debt.
I mean, they surpassed your expectations by far.
I played with it recently. I noticed right away they got rid of the Jabber stuff.
Oh my gosh. I am so happy to not have to deal with running... Oh gosh, what was the Jabber implementation that that Spacewalk had chosen? It doesn't even matter. It was such a pain in the butt.
When I saw that Salt was in there, I thought that was interesting. It's probably the only Salt master type solution that's now outside of VMware that's actually not bad to use.
Yeah, I noticed that. So at my previous employer, we used Puppet, Ansible, and Salt, and we ran separate systems for all of those. So Puppet was managed through Foreman, Salt ran its own Salt master, and Ansible was either self-managed or run through AWX. And it was interesting seeing the different experiences. And it motivated me to look into the baseline. The baseline experience for Assault Master sucks. It is not fun to maintain, and it breaks really easily. So it motivated me to look into the Uyuni Assault Master capabilities, and I came away kind of impressed. Another thing that they did that I thought was really neat was that they basically grafted Ansible support
Yeah, I noticed that too.
into there, and they did it by using Salt as the mechanism for delivering commands. And that allowed Ansible to scale in a way that I've never seen it scale before. Now, I don't know if the Ansible community has been working on something specifically to deal with this, but like it was the first time I ever saw Ansible be responsive and scale well at a large number of machines at once.
There's definitely a lot of work that has been done in Ansible to do that. You know, continue on the vein of bare metal as a service. I did some work on some bare metal as a service stuff a few years ago. It was really interesting. Actually, a friend of mine, he started a company around it. I wasn't going to bring it up, but it's not open source. He's done a lot of really good work. He actually the big inspiration for his work was actually a project called XCAT. That's xcat.org. XCAT is designed for managing high performance compute clusters, but it can be used for nearly anything. It's an IBM project. It is so cool.
It's also written in Perl. Oh my gosh.
It even though it's written in Perl, and I think it's also, I think there's some C in there as well. My memory's right. No, it's Python and some PHP, but it's actually super, super good at what it does. And there's been a lot of talk about zero touch provisioning and zero touch discovery. This has been doing that forever. So I wanted to give that shout out to XCAT, and because it's not something that a lot of people know about.
It's a very neat project. I'm just looking over it right now, and I'm actually really impressed. I've never heard of it before now. It's really cool.
The reason why I know about it is because it was such a huge inspiration for the bare metal work I did a few years ago with my friend Ian. It integrates with a lot of things. For being written in Perl, it's very fast, it's very responsive. It's been around for a long time and gives you a very good way of allowing end users to deploy metal at scale, but it's more declarative. It's still in that declarative. It's not like a Foreman or even or OpenStack Ironic.
Yeah, where you have to declare it programmatically with like with either like config management code or some kind of like actual programming code to like call the APIs and whatever. Foreman in particular, like I think you have to write either Ruby code or you have to use the Hammer CLI to
it's
orchestrate.
All using it's Hammer.
Yeah, you have to orchestrate it that way. Uni, because it is Spacewalk underneath, you basically have to write Python or Java code with XML RPC stuff.
A lot of it is Cobbler.
Now, Cobbler is neat. Like Cobbler is a cool project, and for a while I was a pretty active contributor to Cobbler. And I still think it's actually one of the better projects out there for doing close to zero touch provisioning, because the way it handles it is incredibly interesting. Like you can do a mixture of the latest versions of Cobbler, again, with the wonderful folks at SUSE taking the helm and doing a lot with it lately. Now supports UEFI NetBoot in addition to the legacy PXE boot, as well as the Discovery Disk model. For those who don't know, Foreman and Spacewalk both support a model in which they produce you a special ISO that you can put onto a USB thumb drive or a CD that you then load into a server and boot up with it, and that CD will call out to the server to discover what this machine should be provisioned as, and then bootstrap that process. The idea is that in an environment where you can't have a network boot infrastructure, particularly if you're provisioning over the internet, which sometimes you are, this is a very valuable way to do it. To the best of my knowledge, this isn't actually a particularly common way to do provisioning, but it is a very neat way to do it and makes it very easy to do wide area network-based provisioning, where it becomes difficult to do anything else. Then there's, let's see, and Uyuni also includes something that I thought was pretty unique among all the bare metal service providers software, is the ability to craft images for those machines in the system itself through its own UI. So it integrates the Kiwi image build tool into its front end so that you can create images for either virtual machines, containers, or the actual bare metal machines you're provisioning to right from the interface, and you can then tag them to be shipped out to these different workloads and whatever. This is the first time I've seen a full service way of handling all these things in one solution. And it kind of blew my mind that I had never seen it before. And it's such a, like, on the face of it, it's such an obvious idea. And I always wondered why I've never seen something like that before.
I did not notice that I was just seeing where things had landed, installed it, blew away the VM. So I did not notice Kiwi, which is great. I have fond memories of Kiwi because of SUSE Studio.
I miss SUSE Studio. My first experiences with making images for my own deployments and stuff was using SUSE Studio. They even helped you figure out how to replace all the branding and put your own wallpapers, logos, the whole works. It was super nice, and I wish solutions like that were still around, and they're just not anymore.
What about something like Image Builder built into Cockpit? Is there a future for something like that? Expanding upon it, talking about bare metal and bare metal as a service, could you see something like that management vision copied and implemented into Cockpit somehow? Because to me, Cockpit is the last stop. It has the potential to be the last stop of system administration. You know, you're talking about making self-service more accessible. And to me, Cockpit is kind of a model example of how you can make self-service more accessible. And I'm always looking at ways which Cockpit could be extended for more functionality. And I know that there's an image builder baked into Cockpit. Do you guys see something like what you're talking about with Uyuni and Kiwi maybe being baked into Cockpit somehow someday?
I think it makes a ton of sense, actually. Like, at the level of where you're operating, like, maybe a simple architecture with a few machines, like, Cockpit is great for that kind of stuff. And yeah, as you mentioned, there's a self-hosted version of Red Hat's Image Builder service that you can install into a local Cockpit deployment on a server. And that thing can produce virtual machine images and stuff like that. I think the next step would be creating an interlink between Cockpit virtual machine management and Cockpit's Image Builder, so that when Image Builder knows that the machine is provisioned with virtualization resource capability, that it can put those images into the virtualization store so that you can boot them up right in the environment. And that would actually be like a good way to get to that level for at least basic tier kind of stuff. I think the next level tier would be probably seeing, I'm going to say corporate-y, product-y names instead, because there's not really a non-product-y version of this. So Red Hat has a hosted image builder service. That's part of, if you get a RHEL subscription, either a Red Hat developer subscription, or if you're a business that pays for Red Hat Enterprise Linux, with Red Hat Insights, you also get the Red Hat Image Builder service. That Red Hat Image Builder service could also be integrated into Red Hat Satellite. And so if you have Red Hat Satellite, you could, like, in the future, I hope, you could see like integrations between Red Hat Satellite and the Red Hat Image Builder service to make it so that you could consume those images that you produce and then provision them willy-nilly for bare metal or virtual machine or container workloads. From an open source perspective, That would mean like Foreman would get the ability to communicate with an arbitrary image builder service, and maybe the Red Hat Satellite one would default to the one from Red Hat or whatever. And that would actually be great because I think for secure environments, people tend to rely on Red Hat Satellite being their equivalent shop to the stuff that you get from RHSM. And seeing Satellite have that capability, Foreman having that capability, I think would be pretty cool to see. It's a good idea, and it's a definitely, I hope, a logical step that comes in the future of those projects. What do you think, Brandon?
On the image builder, I think you can essentially do some of that today, but it's still a lot of steps that you would have to write. There's not a built-in mechanism. So if I wanted to build an image for a VM with Image Builder, I can build that image, and when it's done, copy it or move it to the virtual machines, to your virtual machine data store, or move it or upload it upload it to OpenStack. I believe there is a mechanism for OpenStack and like AWS built into the tool already to upload them to the image store service in OpenStack or to an S3 bucket on Amazon. So I think there's some of that, the use case to take a bare metal image, which is available. Like I said, it is basically there, and put it into, say, Foreman or into Ironic. I guess with Ironic, it would just use the OpenStack, but into Foreman specifically, it would, right today, it's a bunch of manual steps. I could easily see that changing. There's a lot of mechanisms inside of Foreman and Satellite for generic files that then can be used that you can then populate into the bare metal side of it. So the Pixie, all the iPixie stuff inside of Foreman.
Actually, this kind of dovetails into something. When I was at Datto, like one of the things we adopted was MAS from Canonical. And the reason we used MAS was because we could reuse our pipeline for producing cloud images to produce bare metal images. MAS is unique among the different providers of bare metal service solutions in that it uses Cloud Init to bootstrap the bare metal environment, which means that you can make the image the same way you make VM images for a public or private cloud infrastructure. And so your whole pipeline becomes super simplified. You can produce a cloud image that has hardware enablement built in, and then ship that to MAS, which can then take that and provision it out to your machines. MAS, out of the box, the open source version, supports CentOS and Ubuntu. I believe the paid version, because it's an open core model, the paid version lets you do more distributions. I suppose with enough of finagling, you could do more with the open source version. But like essentially, the characteristic of being able to bootstrap machines using Cloud Init the same way you bootstrap virtual machines is really compelling because it speeds up the deployment by an order of magnitude. The way that Foreman and Uyuni typically do deployments are based on orchestrating the installer systems that are used for physical machines. So, for example, creating a Kickstart file for Red Hat Fedora systems, or creating a YAST control XML file. AutoYAST, that's it. An AutoYAST file for SUSE systems, or a pre-seed for Debian systems, or I don't actually know what for Ubuntu systems now, since they're changing their installer, and I haven't caught up on what they actually use now for automation.
You can actually also, Neil, just fun fact, you can actually provision VMware ESXi and Windows machines using MAS as well.
Yes, I knew that. I didn't want to think about that very much. I'm very much aware that you could do that.
I'm trying to get you out of your comfort zone a little bit.
I don't want to be out of my comfort zone for that. Windows and VMware can stay right where they are, far away from me. But yes, you're right. The paid version of MAS actually supports Windows as well. It can do sysprep, and it uses Cloudbase Init, which was a Windows port of Cloud Init written by another company to do the same stuff. Underneath all of it, there's a project called Curtain, which is actually quite fascinating because Curtain essentially can orchestrate a bare metal cloud init configuration. And it predefines steps, and it can do things like say, oh, we know that this hardware has these other extra things. We're going to add to the cloud init setup to be yum install more packages to support this hardware or whatever. Things like that. It can also handle, I think, like driver disks and fun stuff like that. But to my point earlier is that it's unique because it doesn't use the installer wizards. And that means that you go from like 1 hour per machine to like 15 minutes per machine. And when you're provisioning thousands of machines, that's a big difference.
Maz is very similar to Ironic and the standalone project for bare metal provisioning from the OpenStack project, Bifrost. So you can do do that as well. It's image based, so you can build a standard image for a specific type of hardware and use cloud in it. A very, very similar concept. And from a admin perspective, like that's really what you want. You want that VM experience across bare metal. I think I feel like we've beat that to death. Is there any other thoughts we want before we move on? Back in the way back time, a lot of companies were making a huge push to just turn their existing environment into a private cloud. Maybe that's not going to happen again. Maybe it would. Right now, there's this huge push with a lot of companies, mostly enterprise scale. They want to be able to manage AWS and Azure in the same way. I've talked about, there's a pseudo labs around Mist.io, which is a CMP, which, and that's its end goal. I've gotten into arguments with folks on this. I personally don't think that that's the right way to go anymore of using a CMP. Even though I'm still a big fan of them. Mist.io, I think, is great. The project that I worked on and actually sold quite a lot of was ManageIQ. ManageIQ is still around. Actual productized version of that, it just isn't sold by Red Hat anymore. It's sold by IBM. The complexity of setting those up and maintaining them, I just don't know if the juice is worth the squeeze.
I think that's the point, right? Like, these management software solutions are tackling the problem from the wrong direction, in my opinion. Like, in my opinion, I feel like these add-on things to try to make it easier to turn your environment into a private cloud, they shouldn't have been at this layer. They should have been in the private cloud solutions in the first place. And I think that's where everything just starts getting messy because, so for example, we've been talking about OpenStack-based stuff for a little while now, right? Most of these solutions are actually around making it easier to orchestrate and manage and scale these deployments. But why? Why isn't this just part of OpenStack itself, right? Any reasonable cloud management, any reasonable cloud system should have a way for scaling itself up and down. And the big miss was that people thought that everybody would be too opinionated about how to do this. I think everybody just wants an opinion. And there isn't one. And that's where I think this is all kind of fallen apart.
One of the goals with CMP at one point, I haven't really been following that part of the industry. It's a pretty niche part of our industry now. The idea was provide self-service on top of traditional virtualization, private cloud infrastructure, and also pull in your public cloud and provide self-service there as well. Be an abstraction layer. I think that works in some spaces, but for most, it's not tenable, especially when you start talking about, I work on all three major public clouds, and maybe I also work with Linode, and then I also have a relationship with Alibaba. And for fun, I have 4 different OpenStack clusters plus a few VMware in there.
Are you suicidal?
No, that was a ridiculous. That's not a real example, but I
hope not.
That was a bit extreme. I know at least one organization that does have all 3 public cloud providers, plus they're on premise. Putting a CMP over all that would just more overhead because you have to then run the CMP, which has to scale out and not just run the CMP. You then need to create the automation, manage the automation, update it as you replace infrastructure, update it as infrastructure gets upgraded. So your VMware environment or your OpenStack environment, you ensure that the automation around that remains up to date. There's just more overhead. I think the best way is, I'm probably a little biased here, but I actually think the best way is using a Kubernetes distribution now across the public clouds, and have Kubernetes, or in the case of what I'm thinking is OpenShift, be your abstraction layer. I know that's not like for everyone. Bill would probably go, Brandon, no one I deal with wants to put OpenShift everywhere. They don't care. They just want it to work.
Well, maybe that's the next phase of OpenShift. Who knows, right? Like, why can't OpenShift be the it just works?
Yeah.
Like I think the distillation of the problem is when you add these other layers of stuff, you're adding too many abstractions to manage. And abstractions themselves are not free. There is no such thing as a free abstraction. And so you have to balance whatever abstractions you're adding with whatever cost value you get out of it.
All abstractions are free.
No, they're not. You stop that with your malarkey there. So, like, for example, a lot of people think of Kubernetes as an abstraction layer around various services or whatever, but it's not designed to be one. Like, you have to be very careful about how you plug things into Kubernetes to give that capability. But like, if you use, for example, EKS or GKE or AKS, you're gonna have different services and different APIs on them. And that's where this concept of Kubernetes being an abstraction layer breaks down, because it's not designed to be one. It's designed to be a toolkit for you to plug in services to build an orchestration platform of whatever you desire. It just happens to be by default mostly containers running in public cloud infrastructure, leveraging public cloud resources. But it could be other things. OpenShift is taking a different approach. Rather than like having to have different services on different architecture platforms or whatever, they pick a set of components that provide essentially a common API layer on top that are then plugged into and managed below to whatever service layers exist, whether it's in a public cloud or a private cloud or just a Raspberry Pi, I guess, right? Like, I guess with Microshift, you could run it in Raspberry Pi. I don't know if you want to, but you could. And you use the commonality of services as an effective abstraction, because you now can guarantee that, hey, no matter which platform I'm on, I have this ingress controller, I have this storage CSI driver, I have this network model, I have this compute resource model, I have this, all these things. And that turns OpenShift, or turns a Kubernetes platform, from being just a toolkit to being an abstraction layer and an actual platform for you to build things on top of. Now, is it complete? Is it perfect? Nothing is. It does a reasonable job at what it does, and it's always continually improving. I am generally excited about the future of how that evolves. I think if they hold true to their philosophy of how they want to simplify and provide value to people who want to do Kubernetes but can't quite grok all of it, I think OpenShift has a lot of promise. And there are other Kubernetes distributions out there that are also looking at this and trying to figure it out. I keep an eye on all of them. It's all going to be very interesting. There's a lot more diversity in this space than there was 10 years ago with the OpenStack stuff, because Kubernetes is an order of magnitude simpler to customize and maintain. Does that necessarily a good thing? Who knows? We might be into a new era of Linux distribution type problems, or it might just all work itself out. Who knows?
I don't know if Kubernetes is simpler.
I mean, from a code perspective, it's like 1/10 the code bases.
That is true. That's true. I don't know if having deployed OpenStack and Kubernetes,
Are you telling me you would willingly just spend all of your days deploying OpenStacks for everyone, no matter what size?
No,
Yes.
no. All I'm saying is that I think they're equally as from a admin perspective. If I'm building a private cloud today, yeah, probably I'd base the private cloud around Kubernetes and not OpenStack, or maybe it'd be a hybrid. I don't know, but the having installed both, I think they're, especially both of them in their early days, they're both equally hard.
I agree that they're
Just in
equally
their
hard. They're
own
just
ways.
I think it's in different ways.
Yeah.
They're equally difficult, but they're difficult differently. Like, for example, setting up OpenStack, you suffer a lot up front. You suffer a lot of pain bringing up all the services and getting them online, getting the networking working, getting the auth set up. But when you're done, it's done and it will work. But now you have to figure out how to keep them going. The problem with in the Kubernetes land is often, I like to compare it to the Jenkins problem. It's very easy to get an initial Kubernetes system up. And then you got to add all the pieces you need to make the Kubernetes system useful. Now you have two problems. You have to upgrade the Kubernetes, and you have to upgrade all the stuff that you installed on the Kubernetes. And this is where Kubernetes distributions start adding value here. They create a tested combination of components that allows them to guarantee, for whatever level of guarantee you could give, that life cycling the clusters are going to be easier. And that's why I think we're seeing OpenShift, Rancher by SUSE, VMware Tanzu, and all these other distributions, because they're trying to figure out how to square that circle. And they haven't yet. Not everyone has necessarily figured it out. And it's still, it's still early days for all of that. But they've all figured out that just providing bare Kubernetes is not enough. That's why we're at the next stage of, like, how do we make a uniform experience? How do we provide a simplified experience? And how do we bring the late stage adoption? How do we get closer to late stage adoption where you can't necessarily guarantee that people are enthusiasts and wanting to dig into all the nooks and crannies to get going with it? I mean, it's here to stay for at least another 10 years, if not longer. We might as well figure out how to make it more pleasant for people.
Thank you, Neil and Bill, for going into this. I think we digressed. I think that's what we do. We're really good at digressing, but I think it was valuable. Again, thank you both for joining me again. Actually, I shouldn't even say thank you for joining me again. You guys are permanent hosts, so I don't need to thank you anymore.
How dare you? I like being thanked anyway.
It's like it's like the first time you go to a friend's house and they ask if you want something to eat or drink, and then after that, it's go to the fridge yourself and get it.
Yeah. So should we be rating your fridge now, Brandon?
Oh, no, that's not allowed. The reason why we talked about this is because private cloud seems to, that discussion seems to be coming back because of hybrid cloud or because of edge, but it is making a comeback. And also I think it's definitely because of that data sovereignty issue we talked about at the beginning, the cost. And that's the case with every type of company, large or small, and probably more so small than the much larger companies. I do think that's a big reason why the concept, maybe it's not what we would describe as private cloud from an industry standpoint, but the concept of bringing things back on-prem, and probably that we're just going to call that private cloud by default. That's really the crux of this. And we'll get more into more of the technology over time. Make sure to subscribe to Pseudo Show on YouTube, and of course, wherever you get your podcasts. Any additional closing thoughts, Bill, Neil, before we head off?
This is going to be one of those things where I think we'll wind up revisiting, and maybe in different interesting ways. Like, I think some of this we could definitely play around and do some interesting content around it. I mean, in the pre-show, we were all talking about the idea of actually doing some of this and providing some video content around how this kind of stuff gets done, partly to run the show itself. We might turn that into some interesting discussions and things of that nature. I'm actually really excited about doing that kind of stuff. So that'd be fun.
Yeah, one of the big things I'm working on is automating the entire workflow, excluding editing because that's impossible. But essentially, how the podcast is delivered to YouTube and to Fireside, who we're currently using, working on automating that end to end, and as well as publishing to the Tux Digital website. So that's that's currently my big project, and I'll be documenting that. We'll do some content around that. Bill, I'll let you close us out.
I learned a lot today. Actually learned I knew more than I thought I did. What you guys always do is you help me take the different parts that I hear, read, see, talk to other people about, and you kind of manage to find a way to fold them all together in a way that I understand. Because things like Kubernetes for old school VM guys like me who live in the MSP world are like grasping at straws. You think you're there, you think you're there, you think you're there, and it's one step further away. So today I feel like I made a step in the right direction, that I'm tackling the ball, so to speak. As always, thanks for listening to The Sudo Show, where business meets open source.